Hello, my name is Daphne Christina Nelson and my register number is URK23AI1033. This is experiment 6 of Deep Learning Laboratory Long Short-Term Memory LSTM. In this experiment, I demonstrate how a long short-term memory or LSTM network can be used to generate text character by character. Based on sequential patterns learned from the dataset, I used a Shakespeare-style dataset containing lines of text that the model learns from. Let's get into the code for more detail. So this is the complete execution of the code and with the output. Let me explain it line by line or section by section. The dataset was first preprocessed by converting all text to lowercase and mapping each unique character to an integer. I then created sequences of characters as inputs and the next characters as the targeted output. This prepares the data so that the LSTM can learn which characters tend to follow others in a sequence. The model consists of an embedding layer to represent characters in a dense space, followed by an LSTM layer with 128 units and a dense output layer with softmax activation. Model was trained using the categorical cross entropy as you see here. Wait. And the optimizer used is as usual Adam to predict the probability distribution overall characters for the next step in the sequence. After training the model successfully, here is the complete output given. So, it has generated new text by predicting one character at a time using a small seed sequence. The generated text resembles Shakespeare's style, forming phrases and words that follow patterns from the original dataset. Using probability sampling, the text becomes more varied and avoids repetitive sequences. For example, here to be or not to be me, others see sends arrows to suffer the troubles, or these are resemblance of Shakespeare's textbooks and the way of him writing a notebook. So let's get back to our record work. This is my complete record for experiment number 6 with aim, description, program, output, and the result screenshots with conclusion. So, in real world applications, LSTM based text generation is used in chatbots, automatic story writing, language modeling, code generation, and even AI assisted content creation. It demonstrates how neural network can learn sequential dependencies and produce human like sequences. To conclude, this experiment successfully demonstrates that LSTM networks can capture the patterns and structure of sequential text and generate coherent creative outputs, highlighting the potential of deep learning in natural language processing. Thank you for watching.